Investigate the concept of Pascal triangle and show how it is formed. The Pascal triangle is a system of numbers arranged in row resembling in a triangle with each row consisting of the coefficients in the expansion of 4, this 0, 1, 2, and 3. Named after the French mathematician Blaise Pascal, is an easy way to find the coefficient of the expansion. Each row in the triangle begins and ends with 1. Each element in the triangle is a sum of two elements immediately above it. It is formed of the next shape, a triangle.
How do the coefficients of the expand binomial relate the numbers in the Pascal triangle? Just because the number of the Pascal triangle are the numbers that are used in the binomials, depending the row of the exponents that the expression has. Each row gives the combinational number, which are the binomial coefficients.
I'm going to explain the question number 4. How does the number of terms in expansion of a plus b elevated to n relate to the degree n? To find the number of terms that a binomial will have, we must know that there always will be n plus 1 in the expansion of a plus b elevated to n, where n is the exponent that the binomial is
Investigate
worth.
the formula and meaning of the binomial theorem and write this down. The binomial theorem is used to describe algebraic expansions of power of the binomial. In other words, it can also be called a quick way of expanding a binomial expression that has been raised to a certain power. The formula of the binomial theorem for a positive number is this. And also it can be represented as this formula that is more short than the other one. But it can also be useful for the problem that we are
Theorem to expand expression. Parentheses 2x plus y elevated to the power 2 close parentheses elevated to the power 6. In this binomial we have two variables, 2x and y elevated to the power 2. They are affected for the exponent number 6 that told us that the number of terms that we are going to have in this binomial are 7 according to the formula n plus 1. Then, to obtain the coefficients, we have to do the Pascal triangle, and it is give use for the row number 6. That is our coefficient, the number 1, 6, 15, 20, 1, 15, 6, and 1. And we are going to put in order to the numbers at large of the binomial and the moment we have this.
Then, with this information, we can put 7 terms, but always having in account that the first and the last term will be a elevated to a power and b elevated to a power that represents 1 parentheses 2x elevated to the power 6 and 6 parentheses y elevated to the power 2 and elevated to the power 6. Okay, so we already have the first two terms, but we also need to obtain the other exponents for the rest of the terms. So we are going to use a law that in the Precalculus book told us the exponents of a decrease by 1 from term to term, while the exponents by increases by 1. And if we start of x elevated to the power 6, we are going to finish with x elevated to the power 0. At the same time, if we have y elevated to the power 0, we are going to finish as y elevated to the power 0. So our binomial is this one. And finally, we solve the equation, and the result is this.
Find the first three terms in the expression of this. This question just asks you to obtain the first three terms, so in the Pascal triangle row 10. This is the exponent of the binomial that we are using. We are just going to take the first term that are 1, 10, and 45. At the moment, we know that the terms with the variables are, with the 1, 45. Finally, we have to obtain the exponent for x, but as we know in base of law of the increasing of exponents, if we start in the first term with y0, for the second term we are going to have y1, and for the third term we will have y2. So if we do, or in binomial recapitulation all the information, we have to obtain this equation with the first three terms are the following.
B. Find the seventh term in the expansion of a plus b elevated to the power 20. As we know with the formula n plus 1, we can know that this binomial have 21 terms. But we just need until the seventh term, so for this special reason in the Pascal triangle, we are going to watch in the row at the first 7 numbers that are these. And our 7th number is this. So we are going to use a number for the 7th term, and at the moment we know that our term without exponent is the following. This.
And finally, to obtain the exponent for this term, we just have to rest or add the number 7 at the number that you start according the law of decrease and increase. That is to say that if with the variable you start with the number 21 and the term with decreasing, you have to raise the number 7. That is the term that we search. That is 21 minus 7. That is equal to 40. And so that the moment we know that the exponent of the variable is 40. And for the variable, it's opposite, because if you start at b with the exponent 0 and it's increasing, you have to add at the 0 number 7, so you will obtain 0 plus 7, which you will have a result of 7. And so it is to say that the exponent of the variable be 7, and with this information you can create your 7th term that finally is this.
Conclude as a team that expand a binomial is not a hard procedure. It's just that you have to know all the steps to obtain each of its parts, and also you have to know how to do the basic operation at the perfection. Our results for our special part as a team are the next.